We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
All right, let's go over B. In the intro, you're just supposed to copy the 5 steps from A0 there. You can press pause and do that, or hopefully you just copied it from above. And it tells you to copy down B0, and then from B1 to 4, only pick 2, but of course I'm going to go over all of them. So, question number 1, in order to solve here, we're going to isolate the radical sign. And I like to draw a line down my equal sign here. And it is isolated, which means that on the right side, the radical sign is by itself. There's nothing in front and there's nothing behind. That is a good thing. So let's go ahead and just identify the index, which is a 2 here. So now I'm putting a square on both sides. This will cancel. This and the radical sign are gone, so you're left with 4x plus 9. And over here, 3 plus x squared. Okay, remember, you do not distribute the 2, the exponent there. What that means is that you have 2 of these. And to solve that, you're just going to use the box. You're basically multiplying. So I have 3 plus x, 3 plus x. 3 times 3 is 9, 3 times x is 3x, 3 times x is 3x, and x times x is x squared. So that blue box above, this becomes, from the inside of the blue box to the left there, x squared plus 6x plus 9. I just combine like terms the 3x's. And over here I have 4x plus 9. Well, if you recognize that we have the highest power is a 2, if I set it equal to 0, then I can use my methods of solving by quadratics. So let's move everything from the left to the right side. And why am I doing that? Because I don't want my negative, my a value to be negative. I'm going to line up my like terms. So this is 0, this is 0, this is 0. I have x squared plus 2x equals 0. And then here, all I'm going to do is factor. I'm going to take out my GCF. Now that they're factored, I can solve by setting this equal to 0. So this is what we learned in first semester, zero product rule. And then we're just solving. So x equals 0 is already one of them. And if I subtract 2 here, I get x equals negative 2. Okay, now these are our 2 possible solutions, and I'm going to have to test those by checking my answer. So check here. Let me just write it once, and then I'll copy and paste. 3 plus x equals the square root of 4x plus 9. Okay, and the first one we're going to test is x equals 0 in orange. So every x value, I can put in 0. And let's just see if this works. Are they going to be equal? So I have 3 plus on this side, and square root of 4 times 0 plus 9. This side's going to be 3. And I'm going to get 4 times 0, which is 0, and 0 plus 9 is 9. Square root of 9 is 3. So does 3 equal 3? I'm going to put a check mark right here. What does this tell me? This one down here works. Okay, let's go ahead and test negative 2 here. Every x value I'm going to put in a negative 2, so we're checking our answer now for the second possible solution here. So 3 plus, and we're not sure if it's going to be equals 2. 4 times negative 2 plus 9. So 3 plus a negative 2 gives me 1. Here I get negative 8 plus 9. And that equals positive 1, and the square root of 1 is 1. Are they equal? Yes, they are. So that means my two solutions for B1 is going to be 0 and negative 2. Let's go ahead and try B2. We're going to do the same thing over here. I'm going to put a line down my radical sign. The radical sign on the right side is already isolated, which means by itself. This 2 here is my index or root. So using the steps above now, I'm going to go ahead and square both sides. Squaring on both sides is going to eliminate this 2 and the index of 2 and the radical sign. So I'm left with 2x minus 9. On the left side, you're going to have x minus 4 quantity squared. So do not distribute the 2. Do not distribute the exponent. This essentially just means that you have 2 of these expressions. And if you, let's just do it down here. X minus 4, x minus 4. Let's go ahead and just multiply and then combine like terms. X times x is x squared. X times negative 4 is negative 4x. Negative 4x and 16. If I combine like terms, which is just these two, which just basically means just adding, so I'm going to have x squared minus 8x plus 16. Okay, if you recognize that the highest power, we're trying to solve for x here, and to get x by itself, we're going to have to solve by using quadratics. So I'm going to move everything to the left side because I want my a value to be negative. So I'm doing the opposites. Kind of doing 2 steps in one. So here you'll notice that my number in front of x squared is a positive number. And those just equal 0. Look at here. How do I solve this one? A trinomial, power of 2. Well, what's half of 2? It's 1. And you have an A, B, and C. What can we do here? We can factor. You guys remember this? Yeah. A times C is 25. My B value is negative 10. And my two numbers that'll multiply me negative or positive 25 are negative 5 and negative 5, and two numbers add to be negative 10 are negative 5 and negative 5. So I have x minus 5 and x minus 5 equals 0. You have here the zero product rule, so we're just going to solve for that. We're going to set each of these equal to 0. And it's the same thing, right? So you just add 5 to both sides. You'll get x equals 5 and x equals 5. Now, here's the good thing. You don't need to test it or check it twice because it's the same number. Okay? So let's go ahead and check this now. You're just going to write the original problem. And we're not sure if they're equal, so we're going to head and substitute in x equals 5 for every x value. Five minus 4 is 1. 2 times 5 is 10. 10 minus 9 is 1. And the square root of 1, two identical numbers that multiply to be 1, is 1. So that means that both of these are solutions. Let's go ahead and try B3. In B3, you'll notice that the right side is isolated. Remember, there is nothing behind it, and there's nothing in front of that radical sign. Next thing I'm going to do is identify the index or root, which is a 2 here, and that tells me that I can now square both sides. If I square both sides, then this 2 and this 2, and the radical sign are gone. So we're left with just x plus 2. And on the other side now, be careful. You cannot distribute that orange 2 there, the exponent. Okay, it just means that you have 2 of them. And if you have 2 of them, then you're going to have to be doing, we learned back in first semester of the box. You're going to have 2x minus 2, 2x minus 2, and we're just going to multiply here. 2x times 2x is going to be 4x squared. 2x times negative 2 is going to be negative 4x. 2x times negative 2 is going to be negative 4x. And negative 2 times negative 2 is positive 4. If I add those two together, that'll be negative 8x. So you'll have 4x squared minus 8x plus 4 equals x plus 2. In light blue there, this is called a quadratic, and to solve quadratics, we're going to have to set it equal to 0. So we're going to move everything to the right, to the left. It sounds like a dance. I'm going to subtract x, and I'm going to subtract 2. Why did I do that? Because this will equal 0. This one equals 0. I'm left with 4x squared minus 9x plus 2. Okay, so here I'm hoping that we can actually factor this. That would make our lives a lot easier. So let's go ahead and try to factor this thing. A, B, and C. A times C is going to be 8. My B value is negative 9. Two numbers that multiply to be 8 are 8 and 1. 8 and 1, and I want them to add to be negative 9, so they're both going to be negative. Okay. So now I'm going to have to use the box because A is greater than 1. So this is negative 8, negative 1. No, 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 no. Oh, that's right. Okay, so these are x's because basically the negative 8x and the negative 1x, we're splitting the middle term, negative 9x. So the 4x squared goes into the top left, and the positive 2 goes in the bottom right. Okay? What is the greatest common factor in the column here? It is going to be a 4x. Going the other direction, it's going to be an x. This one looks like it's going to be negative 1. And this one has to be a negative 2. Because that would give us negative 2 times 4x gives me negative 8x. Negative 2 times negative 1 gives me positive 2. Okay, that one works. So when we factor this, we have 4x minus 1, x minus 2. Now to solve these, we're going to take these and we're going to set each of these equal to 0. This one in a different color, x minus 2 equals 0. So this one is x equals 2. And this one over here in light blue, remember PEMDAS going backwards, so add 1 to both sides instead of dividing by 4. We get x equals 1/4. Okay, so these are my two possible solutions. Let's go ahead and test these out. 2x minus 2 equals square root x plus 2. I'm going to write this twice. I want to separate both sides. And let's go ahead and do this one right here. X equals 1/4. So every x value, we're checking it here. Check. Okay. I have 2 and then minus 2, and then this one's going to be plus 2. you can do, let's just leave it as multiply across. You get 2/4 minus 2. And I get this 1 over 1. I want to subtract fractions, so the denominators or bottom of the fraction has to be the same. So 4 over 4. So this will give me 2 over 4 minus 8 over 4, and that'll give me negative 6/4. You don't have to reduce it. Let's see what happens over here. Okay, same thing over here. I'm going to multiply this one by 4 over 4. So this is going to give me 1/4 plus 8 over 4. And you can add the numerators, so you get 9/4, which is the same thing as the square root of 9 over the square root of 4. And square root of 9 is 3. Square root of 4 is 2. And then over here, we should just, you can reduce this. Negative 3 times 2, 2 times 2. This will give you negative 3/2. And this one's a positive 3/2. So what does that mean? They are not equal. Okay, so that positive 1/4, I'm going to put an X by it. This is an extraneous solution. It was a possible solution, but when we put it back in and checked it, it didn't work. Okay. All right, let's go ahead and check x equals 2 and see if we have some better results. We're not sure if they're equal. So 4 minus 2 gives me 2. 2 plus 2 is square root of 4. Square root of 4 is 2. Okay, so the answer in this problem is only x equals 2. X equals 1/4 was an extraneous solution. All right, let's take a look at letter B4 now. Same thing. Separate the sides. The radical sign on the right side is isolated. The index there is an invisible 2, so I just need that number to square on both sides. I'm going to get x plus 2 squared. Over here, this 2, and the radical sign cancel, so you're just left with 3x plus 10. Okay, you wouldn't do something like square root of both sides because you can just simplify it. So the exponent tells you have 2 of them, right? And I can just do a side problem. X times x, x squared, 2x, 2x, and 4. So this will give you x squared plus 4x plus 4, because I combine like terms there. And that's the same thing, right? So 3x plus 10. All right, let's move all of the right side to the left side. So subtract 3x and subtract 10. This will give us x squared plus 1x minus 6 equals 0. In blue there, I'm going to, hopefully it can factor. A times c is negative 6. B value is 1. My two numbers are 3 and 2. I want the multiply to be negative, so one of these has to be a negative. And if I add those together, it equals a positive 1. So I have x plus 3, x minus 2. And then you can set each of those equal to 0 based on the 0 product rule. And if you just subtract 3 there, you get x equals negative 3 and x equals positive 2. Let's put these in 2 different colors here. So I have a pink possible solution and a light blue possible solution. Now we need to check our answer. So let's go ahead and check. X plus jack. Do this twice. So the first thing I'm going to do is let's test the negative 3. Everything else is the same. And negative 3 plus 2 is a negative 1. Negative 9 plus 10. And negative 9 plus 10 is positive 1. Square root of 1 is 1. Are those equal? The answer would be no. So this one is not. This is an X, extraneous. It was a possible solution when we solved it at first, but when we put it in, does not make it true. Let's jump in and do this one now, making X equals 2. Two plus 2 is 4. 2 times 3 is 6. 6 plus 10 is 16. Square root of 16 is 4. So 4 equals 4. This is good. That means that my only solution in this problem that works, if you want to, you could put a star by it, is X equals 2. Okay? Let's go on to now B. All right, let's go over B5, and I want to make sure that the radical sign is isolated. There's nothing behind it, in front of it, which it is isolated, and then we can just identify the index, which is 3. That's important to us because then now I can do this. I can each side do the third power. So I'll get x to the third. This 3, that 3, and the radical sign are now done away with. So I have just 2x squared plus 8x. Okay, so I want to solve this. Solving polynomials means finding the x-intercepts. Finding x-intercepts means the y is some number. The x is some number when y is equal to 0. So what does that mean? You just want to make it each side equal to 0. So I'm going to move all of this to the other side. And notice these are not like terms, so you can do something like that. But you kind of want them in order. So you'll get x cubed, this one. Then this one, negative 2x squared minus 8x. Okay, some of the tips we had were back in intro video was factoring. Do you notice anything? Some things that you should notice is that you cannot put this into X box method of factoring. Why? What is half of 3? It is not 2. But you should always be thinking about, yes, the GCF. The GCF I know is each of them have an X. So let's pull an X out. In some ways, that's just kind of like dividing by X. Okay, here on the inside now, let's see if we can factor using the orange there. A times C is negative 8. My B value is negative 2. My two numbers are going to be 4 and 2. I want them to multiply be negative 8, so negative 4 times 2 equals negative 8. Negative 4 plus 2 is negative 2. All right, now we're going to apply the zero product rule to each one of these. And x equals 0, x equals 4, and x equals 2 here. I'm going to try to use 3 separate colors because we're going to have to check each one of these, the orange, blue, and the light blue. Okay? Let's put that in here. So I have x cube root 2x squared plus 8x. And now we'll use my copy and paste. Hey. Paste. There it is. I feel like Captain America throwing that shield. Paste. Yes. Okay. Let's do the orange one first. 0. Okay, we're testing this. And this will be a 2, squared plus 8 times 0. Okay, so we get 0. Remember, you're using PEMDAS here, so exponents of 0 times 0 is 0. 0 times 2 is 0. 0 plus 8 is 0, and cube root of 0. 3 identical numbers that multiply to be 0 is 0. What does this mean? This one is a solution. It checked. Okay? Let's go ahead and do x equals 4 now. X equals 4. Uh-oh, forgot one. That's 4. Okay, 4 equals the cube root of, again, PEMDAS, so exponents first. 4 squared is 16. 16 times 2 is 32. And 8 times 4 is 32. And this will give me 64. 3 identical numbers that multiply to be 64 is 4. So 4 is equal to 4 for our light blue. This is also a solution. And the last one we're going to be using is 2. 2, 2, 2. And when you're doing a substitution, put in parentheses, keeps you organized. Don't forget the cube root there. And then we just go ahead and simplify this. 2 equals, now remember exponents first, so 2 squared is 4. 4 times 2 is 8. 8 times 2 is 16. 2 equals the cube root of 8 plus 16 is 24. And there are no 3 identical numbers. Made a mistake. Oh, I did it. Let's see. Okay, so this was a positive 2, which means I should have put it here positive. Positive, so that means this is a negative 2. So what we're testing is a negative 2. Okay, let's go double check our answers. This is a negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16. It happens. I make mistakes. Okay, so this is good. 8 minus 16 is negative 8. 3 identical numbers that multiply to be negative 8 are negative 2. And that checks. Which means for B5, all of these are solutions, all 3 of them. Remember, you're going to have to isolate, set it equal to 0, solve, and then check your answers. That was B5. Let's try B6. Okay, this one is isolated. There's nothing in front or behind it. Okay, now we're going to identify the index, which is this one right here. So I'm going to do the third power to each of these. Okay. And on the left side, negative x to the third power gives me negative x times negative x times negative x, which is negative x to the third power. Over here, you're just left with what's inside, which is x squared minus 12x. This 3 and 3 in the radical sign go away. Okay, do you see how the left side, that value is negative? I don't want a leading coefficient, the number in front, to be negative, so I'm going to add this to the side. Okay, you just got to think ahead. This will equal 0, x cubed plus x squared minus 12x. Okay, we cannot factor this because half of 3 is not 2. So we're going to have to take out the greatest common factor, which is an x. So I have x squared plus x minus 12. Okay. And here in the blue right there, we're gonna factor. So let's try to factor this. A, B, and C. A times C is negative 12. B value, there's no number there, so it's a 1. My two numbers are going to be 4 and negative 3. 4 times negative 3 gives me negative 12, and 4 plus negative 3 gives me 1. Guys, there is a reason why we spent a lot of time the first 3 weeks of school plus another unit on factoring, because this came up so much. Okay, so you have the x. The 4 is positive and 3 is negative. And we're just going to apply the zero product rule. So x equals 0. That will give you x equals negative 4, because you subtract 4 on both sides. And then x equals 3. I'm going to put this one in dark blue, light blue, and pink. And we're going to have to test each one of those versus the original problem. So negative x equals the cube root of x squared minus 12x. Let's do some magic. Boom. Let's do it down here. Come to me. I recognize when I speak with authority, it'll go in. Okay, so let's test x equals 0 here. Opposite of 0 is 0. I have the cube root. 0 squared is 0. Negative 12 times 0 is 0. So 0 minus 0 is 0. The cube root of 0, 3 identical numbers that multiply to be 0, are 0. So this checks. What does this mean? This is a solution. Let's go ahead and test now x equals negative 4. Remember, put the substitution in a parentheses. Let's go ahead and simplify this. Now I'm just writing everything that we didn't substitute. And negative, opposite of negative 4 is positive 4. Negative 4 squared is 16. Negative 12 times negative 4 is positive 48. 48 plus 16 is going to be 64. 3 identical numbers that multiply to be 64 is going to be 4. This is true, which means I keep all of them. All of x equals negative 4. And the last one, let's go ahead and test x equals 3. Boom, here, here. Da-da, da-da, and da-da. Opposite equals cube root squared minus 12. Okay, simplify it. Opposite of 3 is negative 3. 3 squared is 9. Negative 12 times 3 is negative 36. 9 minus 36 is negative 27. And 3 identical numbers are negative 3. And this problem, I'm showing it to you a different way. These are opposites, right? This 3, the index or root of 3 with a radical sign. And this one, so you're just left with negative 3 equals negative 3. And that is true. So that is a solution for ours. So that is B6. All right, B7, I have them somewhat isolated. But what I'm going to do is I'm going to square both sides. The left side is isolated. Remember the index here is 2. And I'm going to do the same thing over here with 2. This one cancels, cancels, cancels. You're left with 3x minus 5. Now, on the right side, remember the power of 2 means there are 2 of them. And if you have two binomials like this, you can use your box method, or in some textbooks they call this the FOIL method. So let's go up here and let's go ahead and multiply. 1 times 1 is 1. 1 times negative square root of 2x is negative square root of 2x. 1 times that number is still negative 1. You can put that in 1 if you want. 2x. Okay, now negative times negative is positive, and it's radical 2x times radical 2x. And remember, these can go inside the same radical because they're multiplying. So you essentially have 4x squared, and remember that would simplify to square root of 4 is 2, and the square root of x squared, you're going to have x. So here are my answers. And if you put that all nice kind of together, you're going to have these two are going to become negative 2x. Negative 2 times square root of 2x plus 2x. Okay? So that's what happened when we did this one. And this side is 3x minus 5. Okay? All right, let's go ahead and let's move everything to the left side if possible. So I'm going to subtract 2x. I'm going to subtract 1. We're going to get 1x, so x minus 6. And we have negative 2 times the square root of 2x. Okay, from here, I can take the square root of both sides. Let's make this way longer. Okay, again, x minus 6 on this side. When you use your box method, let's do it over here, I've got space. X squared, negative 6x, negative 6x, and positive 36. Combine like terms, you get x squared minus 12x plus 36. Remember, you multiply and then you add. Okay, over here, this one is negative 2 squared and the radical 2x squared. Okay, and negative 2 squared is 4. And remember, these cancel. 2 and 2 and the radical sign, you're just left with 2x. So this would give me x squared minus 12x plus 36 equals 4 times 2, which is 8x. And then if I just move that over, you'll get x squared minus 20x plus 36 equals 0. Okay. From here, I'm going to see if we can factor this. So A times C is 36. B value is negative 20. Two numbers that multiply to be 36, but add to be 20 are 18 and 2. And if I do both negative, negative 18 times negative 2 is positive 36. Negative 18 plus negative 2 is negative 20. So there are my factors, right? I'm just... Okay. And then if you just zero product rule, add 18 both sides, x is equal to 18 and x is equal to 2. This is blue, and this is pink, okay? Okay, let's go ahead now and test each one of these. Let's check our answer. I'm gonna write this once and then I'll just copy and paste. Okay, so we said that we would do 18. So let's go ahead and do 18. 18. 18. So I have 3 times 18 minus 5 equals 1 minus square root of 2 times 18. 3 times 18 is going to be 54 minus 5. 1 minus the square root, or 2 times 18 will give me 36. Square root of 36. So 54 minus 5 is 49, and the square root of 49 is 7. Square root of 36 is 6, and you'll get 7 equals negative 5. Can 7 equal negative 5? That is not true. So 18 is, I'm putting a big X as a no. This is an extraneous solution. Okay, let's go ahead and test negative 2 now. Okay. Negative 2. Negative 2. PEMDAS, and remember it's multiplication, so that'd be negative 6. Negative 6 minus 5 is going to be square root at negative 11. And you're going to have over here 2 times, stop, I did it again. It was an x equals a positive 2. So that would be 3 times 2. A positive 2 is 6. 6 minus 5 is 1. And then over here, square root 2 times 2 is 4, and the square root of 4 is 3. No, square root of 4 is 2, and 1 minus 2 is negative 1. Square root of 1 is 1. Can 1 equal negative 1? That is no. So that means that this is also an extraneous solution. And if they're both extraneous solutions, then our answer is going to be no solution. Let's do a different color I've never used. So the final answer is, whoa, that's really big. No solution. Okay, when they're both extraneous solutions, then the answer would be no solution for B7. Let's try B8. Let's do the same strategy we did on the other side. The left side is already isolated, so I can go ahead and just square both sides. The index is 2, they will cancel, and you're going to be left with just x plus 1. On the right side, you have 2 of these. Okay, I'm going to do the same thing. I'm just going to use the box method. And this will be square root of 2x plus 1, and this one will be positive 2. Square root of 2x plus 1 and plus 2. Okay, so here, when you're multiplying, you have 2 of these, right? Square root of 2x plus 1 and the square root of 2x plus 1, right? You multiply them together, you have an exponent, as I'm trying to point out. Oops. So this would be the square root of 2x plus 1 quantity squared, which I'm trying to say is then these will cancel, and you're just left with 2x plus 1 for this one, that box. Okay, so this would be 2 times square root of 2x plus 1. This one will be 2 times the square root of 2x plus 1, and 2 times 2 is 4. So these are my answers. Now, this one here in pink, you can combine. So let's go ahead and write this out. 2x plus 1. The pink one I said is you adding 2 plus 2 is 4. So 4 times 2x plus 1 plus 4. Let's do that in white. I have x plus 1. Okay, what I'm going to do now is I'm going to move everything that's not in the radical, everything in white, to the left side. So subtract 2x. I'm going to subtract 1 and subtract 4. We are going to get that one 0. 1 minus 2 is negative x minus 4. And over here, 0, 0, 0, and then 4 times 2x plus 1. What we're going to have to do here is your favorite. We're going to have to take the square root of both sides. Again. Because it's so fun. I know what you're thinking. This is long, but there are longer math problems. Okay, so I'm going to go ahead and write negative x minus 4, negative x minus 4. And let's get an answer. Because remember, this is negative x minus 4 2 times. Negative x times negative x is positive x squared, 4x, and positive 16. So x squared plus 8x plus 16. Okay, over here, you could do it like this. 2x plus 1. 4 square root of 2x plus 1. And 4 times 4 is 16. And remember, if you have something like this, you have 2 of them, right? Remember this and that 2, they will cancel. So you're just left with 16 times 2x plus 1. So we can distribute. So 32x plus 16. And then I'm going to go ahead and subtract everything to the left side. 32x minus 32x minus 16 minus 16. That's a 32x. And this would give us, give me more colors. This would give us a 0 there. That would be nice. X squared, and that would give us 2, 6, negative 24x equals, all of this would be equal to 0. Okay. So then I'm just going to factor out a GCF, solve it, 0 product rule, and you have x equals 0 and x equals 24. Okay, so now on this problem, on B8, we're going to do the same thing. We're going to have to check our answer. So let's check it. And just write it out. And then magic, copy and paste. Oh, I can just duplicate it. That's better. Duplicate. Da-da. Save the step. That's math, guys. Just like, right? No? Are you following? Let's check this. All right, x equals 0. 0, 0. 0 plus 1. 2 times 0 plus 1 plus 2. So we're going to get square root of 1, which is 1. 2 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. 1 plus 2 is 3. 1 cannot equal 3. So that means this is bad. This is an extraneous solution. Let's try the other one. X equals 24. All right. Square root 24 plus 1. So 24 plus 1 is 25. Square root 25 is 5. 2 times 24 is 48. 48 plus 1 is 49. 49. Square root of 49 is 7 plus 2, which is 9. Can 5 equal 9? No, it cannot. Bad. Extraneous solution, and when they are both extraneous solutions, this means no solution. Whoa, crazy. All right, let's go over B9. Here in B9, you're doing the same thing. You're rewriting, well, I didn't change the directions. I need to do that. But basically you're solving. And to solve, you're basically getting x by itself here. So I like to draw a line down my equal sign. And again, you're going PEMDAS backwards. You're solving, so you're going to do addition and subtraction first. So I'm going to add 4 here. This will give me x to the 1/3 equals 4. Okay, how do you get rid of that 1/3? Well, a lot of times the answer is just going to be x equals, right? But when x is equal, then you really have there's an invisible 1. So how do I make it equal to 1? Well, I would multiply by the reciprocal of 1/3, which is 3, or 3 over 1. If you multiply across here, 3 times 1 is 3, and 3 times 1 is 3, so you get x to the 3/3, and 3 divided by 3 is 1, and 4 to the 3rd power is 64. So x equals 64 in our answer here. And again, we're gonna do the same thing we've been doing. We gotta check our answer. So let's go ahead and write the original. X to the 1/3 minus 4 equals 0. Now remember, you could have done something like x to the 1st to the 3rd power, and then that minus 4 is on the outside. You could have done that. Totally fine. Okay, so x is equal to 64. Remember, the 1/3 power is the same thing as 1 to the 1 over 1/3 power right there. Minus 4, pen died, equals 0. Okay, what are 3 identical numbers that equal 64? So again, if you don't know, go to your calculator. Mine is under math on the left side. And then number 3. So if you have a bigger one, you do number 5, but number 3, whoops, nope. Math, number 4. And we said 64, and then press right, and then enter, that is 4, right? And the opposite, or inverse of that, is 4 to the 3rd power, which is 64. So 4 minus 4 equals 0. So 64 is our answer for B9. Let's try B10. You'll notice that it is isolated. You're essentially doing the same thing. Again, you could have had something like this. 2x plus 5 to the 1st power to the square root, right? Do you see that 1/2? Let me see if I can highlight that for you. Right, this 1/2 is the 1 over the 2. Right here, we just have rational exponents, and so again, it's already isolated, so I just really want to multiply it by its reciprocal so that it equals 1. So I'm going to multiply it by 2, or squaring both sides. Okay, that'll give us 2 over 2. And 7 squared is 49. So 2 divided by 2 is 1, so we don't really need to write anything to the first power. And we can just solve right here. Subtract 5. And divide by 2. We will get x to be 22. Okay, let's check for extraneous solutions. What do you do for checking for extraneous solutions? You just write the original. X is equal to 22. And we just simplify here. So inside you get 44 plus 5, and that is 49 to the 1/2 power. Remember, 49 to the 1/2 power is the same thing as 49 to the first power, and then the index or root is 2. So what's the square root of 49? And that is just 7. 7 equals 7. So this is a valid answer. Now, even in your calculators, parentheses 49, and then I'm going to use the caret button, which is to the right side above the division. And if you do something like 0.5, it will know that it is basically the same thing as 49 to the 1/2. And they know that the rational exponent, so your calculator has memorized it for you, but it's better if you understand it without the calculator. Okay, let's try B11. Okay, you'll notice that this problem is a little bit different because it's not isolated. Again, you have something behind it. Remember, this is just the same thing as this to the first power and a cube root, right? So let's take care of that one first. So let's add 2. I get 4x minus 1 to the 1/3 equals 5. Right? This equals 0. And how do you get rid of that 1/3? You really just want to multiply it by its reciprocal. And that's just 3 over 1, or just 3. So you're basically raising both sides to the 3rd power. On the right side, you get 5 to the 3rd power, which is 125. And over here, if you multiply across, you get 3 over 3, which is just to the 1st power. And if it's to the 1st power, it kind of cancels. You don't need it anymore. You just have this. And we're just going to solve this. Add 1. 4x equals 126. And then if we divide both sides by 4, x equals, let's see, you have 2 times 2, and half of 126 is 63. And you'll notice that the 2's will cancel, and you're left with that. Okay, let's go ahead and check our answer. Write the original. And x equals 63rd and a half. Okay, so I'm just going to do this. 4 is the same thing as 4 over 1. You can just multiply. You're going to get 12 extra 1, 252 divided by 2. And if you divide that, you will get, I'm going to use a calculator now, which I don't have in front of me. Calculator, up here. I'll just do that on my 252. Of course, it's 126. You knew that, right? So 126 minus 1 to the 1/3 minus 2 equals 3. And you get 125 to the 1/3, which is really the cube root. And 3 identical numbers that multiply to be 125 is 5 minus 2, and 3 equals 3. So this one checks out. This is our solution for B11. Let's try B12, same thing. We're gonna isolate it by getting rid of that minus 3 first. Let's make this problem more difficult. A lot of students have difficulties if that negative 3 is in front. It's pretty much the same thing. Do you see this? It's the same thing. I would have to add 3 to get rid of this. So we have x plus 1 to the 1/2 power equals negative 3. Okay, so to get rid of the 1/2, again, let's do this by rational exponents. I want to multiply it to equal 1. So multiply by the reciprocal. Reciprocal just means flip it. Because if you do that, let's do that to both sides. You will get x plus 1 to the 2/2. And negative 3 squared is 9. And 2 divided by 2 is just 1. And you don't have to write 1. So you just have x plus 1 equals 9. And then subtract to get x equals 8. All right, let's check our answer. Let's do it down here. X plus 1 to the 1/2 minus 3 equals negative 6. And we said that x is equal to 8. So 8 plus 1 to the 1/2 minus 3 equals negative 6. I have 9 to the 1/2. Remember 9, this is the 1/2. The 1 stays with the exponent, and 2 is the index or the root, kind of on the top left of the radical. Square root of 9 is 3, and 3 minus 3 is 0. Oh no! 0 equals negative 6. That is not the case. This is bad. This is extraneous. I don't even know how to spell extraneous solution. Okay, so when we said one or both of them don't work, then really the answer is a no solution. Because the solution we found, x equals 8, we put it back in and it doesn't make the statement true. All right, B13. I need to make sure I go back and change those directions. We're supposed to basically solve for each equation, meaning getting x equals 2, and then we have to check for extraneous solutions. Okay. Both sides on this problem have something to the 1/2 power. Well, we're trying to, it's kind of like back in regular equations, you want to get rid of the fraction. Well, in this case, how do you get rid of the fraction? If I multiply by its reciprocal, which would be 2 over 1. And if you do it to one side, you do it to the other, what you're going to get is x plus 2 to the multiply across here. You'll get 2 over 2. Over here, you're going to get, those are going to equal to 1, so you're just going to get x plus 2 equals 10 minus 3x, right? We don't have to write anything to the first power. Like, for example, this x right there is to the first power, but we don't write that. And I will add 3x. And I'm going to subtract 2. So we will get 4x equals 8. And then x equals 2 by dividing by 2, 4 on both sides. All right, let's go ahead and check our answer. Remember, this is the same thing as 1/2 is the same thing as the radical here. And same thing over here, right? This is to the first power, and the index would be 2. So we said that x is going to be 2 based off what we found down here, right? And that would just be 4. And over here you have 10 minus 3 times 2, so that would be 10 minus 6, which would be square root of 4. Square root of 4, which is 2. And that matches, so this is a solution. All right, let's go to B14. Okay, the only difference in this problem is that that one has a negative sign right here, so just got to be careful of that. So again, I'm going to get rid of that rational exponent. It's just a fancy word of saying a fraction exponent, multiplying by the reciprocal, which is 2 over 1. Okay, I can do the whole thing. And over here, this will become just 2x minus 1 to the 2 over 2. Okay, so this one, treat it like a negative 1. So I'm going to multiply the here and here. So this is negative 1/2 to the second power and x plus 6 to the 2 over 2. Because when I multiply 2 times 1/2, that's just 2 over 2. Okay? So that will just become 1, so I don't need the parentheses anymore. Negative 1 squared just becomes positive 1, and I don't need to write a positive 1. So you're just left with an x plus 6, and then you can just solve right here. That's a negative 1x. And let's move this over here. So x equals 7. All right, let's go ahead and substitute that in. Let's check our answer. Let's write the original. And remember, x equals 7 down here. So I have 2 times 7, which is 14. And 14 minus 1 is 13. 13 to the 1/2 power, which is basically square root of 13, right? Okay, this one is 7 plus 6. I forgot something. That negative sign. I'm going to leave that negative to the very end. Okay, so I basically have this, right? But this one is, the big idea in this one is that it's what? Negative. And this one is positive. So are those equal? They are not equal. Okay, so this one is an extraneous solution. Now, this is the only solution I have, so it is a no solution, because no solution actually makes the statement true. Okay, let's try B15. All right, number 15 doesn't look like the previous problems, B13 and 14, but we can make it like that. So remember, the rational exponent, it's just a fancy way of saying the fraction, is x plus 1. There's, whoa, sorry, is the 1 is here, and the exponent, the index is 2. And that's the same thing for x to the 1/2. Of course, we don't write the 1 and 2's. And we will just subtract the square root of x on both sides. And now we will have the x plus 1 squared. The square root of x plus 1 equals 5 minus the square root of x. And we could just now do what we did on the last problem, is you can just raise it to the power of 2. Now, why would I do that? Remember, if you locate the index, which is, the index is 2, right? So if I square this here, on the left side, the power of 2 and the index and the radical sign cancel, so you're left with x plus 1. On this side, you have 5 minus the square root of x, but you have 2 of them. That's what the set of parentheses is telling you. You have 2 of them. And then here, we can use our box. So 5 minus square root of x, 5 minus square root of x. So 5 times 5 is 25. Negative 5 radical x. Negative 5 radical x. And this is negative times negative is a positive. And radical x times radical x. So just think of it as this. Negative times negative is a positive, and then you just have really x squared, which is just x. So these are these 3. Now, these 2, you can combine like terms, right? Add those 2 in front. So you will get negative 10 radical x plus 25 plus x. Okay, we're going to do just like we did on the other side, is we're going to get all the non-radicals to one side. So I'm going to subtract 25, and I'm going to subtract x. So this would give us negative 24 equals negative 10 radical x. Almost there. And what I can do is I can square both sides here. If I square both sides, double check. Yes, and then plus x 25. Yes. Okay. Might be easier if we just divide both sides by negative 1. What this does is it just eliminates the negative on both sides. So I get 24 equals 10 times the square root of x. And then from here, I can just divide by 10 on both sides. So this is 2 times 12, 2 times 5. Cancel the 2's, then you're left with 12/5. 12/5 is equal to square root of x. And to get rid of that, I can just square it. Remember, this 2, the invisible 2, and the radical sign are gone, so you're left with x. The exponent has to go to its multiplying to its exponent. That's the power rule. So that's really 1 times 2. There's an invisible 1 right here. So that would give you 12 squared over 5 squared, which would be 144 over 25. And that's our answer. But we always get the lovely privilege of doing what? Checking our answer. So let's check this original answer here. X plus 1 square root plus the square root of x equals 5. And we're going to use this fraction here. It's not going to be fun, but it'll be fun, challenging. Okay, how do you make 1 a fraction? Just put it over 1. And I'm going to multiply by 25 over 25. So 25 over 25 is just 1. Does that make sense? Awesome. Square root of 144 over 25 equals 5. Okay, so if you add these two, you'll get 169. The square root of 169 over the square root of 25 plus the square root of 144 over square root of 25. And then you have square root of 169, which is 13 over 5, plus the square root of 144 is 12 over 5, so that gives you 25 over 5, which means 5. That means this one checks out. Awesome. Okay, let's do the same thing for B16. And we didn't really leave a lot of space, so I will just write it and do it somewhere else. Okay, magic. And it looks like this line had a lot of space down here. I got it. Perfect. This equals right there. And you know the part where we check it, and you have to write the problem again, so I'm just going to do that right there. And I'll just pencil this off. This is B16. Okay, so let's do the same thing we did in the last problem. I kind of want this idea of the radical isolated, so I'm going to subtract x and get this will be 0. Then I have x plus 13. Remember, you can put it into radical or rational exponents. I'll just leave it as a rational exponent or fractional exponent, and I have 7 minus x. Remember, how did I get rid of that 1/2? I want the exponents to multiply to be 1. So you multiply by its reciprocal, which is just squaring both sides. You'll get x plus 13 to the 2 over 2. And 7 minus x, 7 minus x. Okay? And then this will get you 1, so x plus 13. This one will be, do we have space over here? Let's see if we can do it down here. 7 minus x, 7 minus x, multiply, and then you can combine like terms of those two. So x squared minus 14x plus 49. Okay, and then I'm just going to set it equal to 0. So doing opposites to move it across the equal sign. And this will all equal 0 equals x squared minus 15x plus 36. And to get an answer for that, I'm going to factor using Xbox method. A times c is 36 and negative 15, two numbers that multiply. 36 times 1. 18 and 2, 9 and 4, 13 times, no, 12 times 3, which is my number. And if they're both negative, they will add to be negative 15. So I can just do right? I'm just taking those. You don't need to use the box to factor. And then zero product rule. Oops. So x equals 12 and x equals 3. Pink and blue. Ooh, we have 2 answers. Let's see if I can magic, come to me. Oh yeah, it's still there. That was exciting. Come on. X equals 12. Let's put it in there. So 12 and 12. 12 plus 25, and the 1/2 is basically the, remember it's like a 1 in square root with the index 2. So 12 plus square root 25, which is 5. And then if you do 12 plus 5, you get 17. Does that work? No. You can write no if you want. So this is an extraneous solution. Okay, let's try the blue one now. Okay, x equals 3. I'm going to put it up here. X, 3. X, 3. And I add those together and then take 1/2. So 3 plus 13 is 16, and that would just give me 4. And is 7 equal to 7? Oh, yes, it is. So the only answer in this one is x equals 3. Okay, you do not write x equals 12. The only answer you're writing is x equals 3. Okay, so those were all the examples for B. I ran out of space, so I did it up there.